You're listening to the Joyous Podcast with Mike Carden, where we talk to the world's most interesting business thinkers about life and work and life. Today's guest is Marcus Weldon. For show notes and other content referenced in this podcast, visit joyoushq.com/podcast. And now, here's Mike.
Hello and welcome to the Joyous Work podcast, where we talk work and making work great. I'm Mike Carden, co-founder of Joyous, and my guest today is Marcus Weldon. If you go to Wikipedia, the source of all knowledge, you'll find that Marcus is most well known as the 13th president of Bell Labs, the most famous lab in the world, as well as having served as CTO of Alcatel-Lucent. His name is associated with some of the most important innovations in communications: fiber to the home, 5G, and many foundational networking technologies for the cloud networking era. Well, that's what Wikipedia tells me, but of course this is a generative AI era, so I also asked ChatGPT to write a short poem about Marcus. So here we go. There once was a man named Weldon whose fame in tech had grown and grown. It doesn't seem to rhyme very well, but okay, ChatGPT. With 5G he'd thrive, connectivity's drive, Marcus revolutionized our mobile phone. So I'm not sure if that is a good summary or not, Marcus, but such an honor to have you on the podcast, and welcome.
Thanks, Mike. Yeah, that was not good from ChatGPT, really, but maybe it was actually merited in that it's about what I deserve.
So look, we've got ChatGPT's fairly poor poetic version of you, but I'd love to hear your version of the story. Maybe even how you landed at Bell Labs. Go back that far.
Oh, yeah. So my origin story, as they would say in the years of superhero movies. I was born in the UK, actually, and I went to school in the UK. We were quite low middle class, meaning not a lot of money, but pretensions to be middle class. But I won a scholarship to a private school, so that's relevant because it puts me on a track towards achievement, because it was a very good education I received there. I ended up going to university in the UK, and then at the end of that, my advisor at university says that there's a chance I could make something of myself. And I intellectually disputed that. A typical college student didn't really have much aspiration, and things had come pretty easily to me, so I'm not sure I would describe myself as driven. But he said, in order to make something of yourself, you should go to the US to give you one to do researchy type things, which is the only thing I thought I knew I wanted to do. I didn't want to have a prosaic job. You do that job tour at the end of university, and I got thoroughly depressed that wasn't me at all. I'm a bit of a free thinker, generalist, like to wander intellectually, and it looked like I was going to be sitting in front of a machine. It was a lot of oil data, right? So oil samples were the sorts of BP, things that BP were doing, and so that didn't appeal at all. So I went off to the US and went to Harvard, more again by luck or my accent than them actually.
You accidentally went to Harvard.
Yeah, I accidentally went to Harvard. I think that they had an English quota so that they could establish their international credentials or maintain them. So I fell in the English quota, I went there, did a PhD, and that was actually probably the first formative thing I did, because it really taught me that I could understand anything and become approximately the world's expert within a few years, because that's really what a PhD is you start from a basic education and you become the world's expert in 3 years, and then you write about it for a couple of years and publish it, or your thesis is that. And so I really thought, I could do this. And that's what led me to Bell Labs is during my PhD, the best papers I read, which were always succinct, insightful, and important, came from Bell Labs. And I thought, I've got to go to this place. And I really didn't know much about it, but that's why I went and for a postdoc, and on and on and on. I did reasonably well there. But it was a fabulous place of people like me, and that's probably the best way to put it, which is broadly interested, but also quite detailed. So understanding things with depth and breadth, and didn't want to teach. And that's so they were, I would say, extremely talented academics who didn't want to teach and didn't want to write grant proposals, but they had the intellectual capacity of the top professors, right? So, and perhaps a broader base than most professors end up having. So that was it. And then that worked out well. I did researchy things in physics, chemistry for about 10 years, and then decided I wanted to be more practically useful. And so I started becoming a CTO and a researcher, which was a hybrid role. And that continued on. And eventually I ended up becoming CTO of the company. And eventually I ended up running Bell Labs. And that's the short-ish version of my story. And I've stayed in the US ever since. We can talk about why that is, but one reason is I have a wife and 5 kids in the US, and so it's a good reason to be here.
That was awesome. So just tell me, what does the president of Bell Labs do? I get what a researcher does at Bell Labs, but what does the president actually do?
It actually depends on the personality of the president. Some, it's very much an imperial role. You're the emperor, and you don't get involved in the details. And in the past, some of the presidents had someone under them called the head of research, and the head of research was the person who got into the details of each research domain and project, and then reported up to the president what the hell was going on. I didn't have that role underneath me because I liked to get into the details. So I actually knew and got involved with probably hundreds of projects in Bell Labs, and it's sort of keeping me informed on a quarterly basis, not a daily basis. And then you provide direction, and I think the most important role is to make them coherent. Researchers are brilliant, but they tend to be disjoint or focused on their own domain and their own project. And it's not that they're against working with others, it just doesn't occur to them because most researchers have the slight personality defect or attribute of believing they can solve any problem better than anyone else. And so the thought that someone else could help doesn't really occur to most researchers. They think they can do it better than anyone else. So my job was really just to make sure that the ideas were holistically amassed so that they were more than the sum of the parts, and then guide towards the direction that the industry was going. The other attribute researchers have, they don't understand technology markets and technology productization. So they may have a great idea, but the path to turning that into something you could build and scale and deploy, they don't understand. So my job was to make that path a bit better as well. So yeah, lots of sciencey, techie stuff, but then a lot of business stuff to make it a verifiable product or solution you could bring to market.
Yeah, I'm interested in the businessy part of it actually, to an extent, just because I guess your tenure there coincides with with this growth in communications and computing power that really starts to change the enterprise. Kind of how do you bridge that gap from I guess just pure innovation and R&D into okay, like we're actually here to change the world of work.
Yeah, that's a good one. It was a tough. In fact, if I now am somewhat critical of my role, or maybe some period of time in Bell Labs, I don't think Bell Labs ever completely made the transition effectively from being monopoly owned. And it's not the monopoly per se, it's the fact that company, AT&T, as it was, dictated the future. So it was easy to build the future because the parent company owned the future in terms of commercial deployment. So Bell Labs invented, AT&T deployed, and it was a closed loop. And a lot of the web scales is like that, right? They invent the future of whatever it is they're expert in. Microsoft might be Office products and Office Suite and Google Search and Amazon in Marketplace and AWS, etc. So AT&T was like that, right? You could invent and deploy the future, and you could do amazing things because it was a captive audience. And I think the difficult period to your question is, since that period, it's now an open marketplace. So the innovation has to find its way into an open market. Even if telecom is part of it, you have to work with computing frameworks that might have been developed at Google, right? Or at Amazon with AWS. You have to work on now AI models that are open source or developed by OpenAI or others. And that is a tricky thing to navigate because you've got to teach researchers who might have that mentality of we can invent it all, that in fact there's a lot out there that they need to reuse and repurpose. And even if they do, it's hard to get the telecom industry to adopt that because they always believe they need a special solution in telecom, this thing called carrier grade, which is a bit nebulous. So it was tricky to navigate. I think you've hit a very good point there. And I think a lot of enterprises are going to struggle with that. Their own applications now have to run in the cloud, and they're beginning to do that. But soon it's going to be all their control systems and their robotics and their sensors and their assets are all going to be online, which is not the case today. And that's part of the next Industry 4.0 paradigm. And that's a huge shift in mentality, that they're going to put things that used to be locked up behind either a physical perimeter or a very strong IT perimeter and connect it over public infrastructure. So I suffered with that. I think Bell Labs suffered with that. I think industrials are going to suffer with that same troublesome transition. And I think that's why it's interesting to think about that.
So it's a kind of heavy question, but clearly you're renowned as a big thinker, Marcus. So if you kind of segue from that, what is the kind of future of industrial or enterprise productivity?
Yeah, so I did a lot of thinking on that, Mike. Because why? Well, because 5G was fundamentally premised on not being designed for consumers, although it works for consumers like all mobile technologies. And in fact, the first phase of 5G is very consumerist. But a lot of the design criteria were industrial. And let me explain what that means. Generally, people-to-people networks only need latency on the order of a couple of hundred milliseconds round trip, and bandwidths on the order of megabits per second, and reliability can be good enough, what's called 3 nines, maybe 99.9. In fact, most mobile networks are only 99% reliable, and we put up with it, right? TCP recovers lost sessions, or in streaming services or some other protocol recovers the lost session. But when you go industrial, can you imagine that you said to a machine running a mission-critical process that was cutting something or digging or lathing, that you'll work 99% of the time? On the surface, it sounds good, but that means several tens of minutes a day, it's not working. And of course, there's a catastrophic outcome that might happen because that shutdown, that disconnection is not planned. It just happens because there's some wireless aberration and the thing seizes up, right? And so if it's an autonomous vehicle, everyone gets that. If that vehicle is now out of control for 10, 15 minutes a day, that's a disaster. So that's the big change on going to industrial networks or building industrial networks. And that's what 5G tried to do. So it has very low latency. It has as its design criteria very high availability, 5 nines, 99.999% reliable, and very high bandwidths, because that may be a requirement for some things. So 5G was built for that. And therefore, I spent a lot of time thinking about how is it going to be used? And the short answer is this. Everything in enterprises and industrials started off tethered. It was connected over Ethernet and then some industrial protocols running on top of that. And that gave rise to a certain level of productivity. But tethering means you can't move it. So anything untethered couldn't be connected that way and was only connected over Wi-Fi, best effort Wi-Fi. And lots of things you wanted to reconfigure, but you couldn't because they were wired. And so the whole idea is, if you want to be able to reconfigure any process, production line, robotic system, or have people and robots interact, mobile things interact with those static things, you need to wirelessly enable them. So 5G is designed to basically wirelessly enable every asset you own, whether it's a person, a thing, a robot, a vehicle, a warehouse container, and do that at scale and do it with low latency and do it with high reliability. And the goal is to allow you to reconfigure everything. First of all, understand where everything is, right? I can now see everything. I don't have to wait to plug it in. I can see everything at all points in time. I can compute the optimal configuration I could have, and then I can actually put it in that configuration because everything can move and readjust. And if I do that, McKinsey estimated that there was a 60% improvement in productivity that could be had more or less across the board, because most enterprises and industrials do a set of similar tasks: move things, manufacture things or assemble things, store things, ship things. All of that is common, and that could be a 60% improvement in productivity if I could have this optimization of being able to continuously see, optimize, reconfigure. And that's why it's a huge shift for industrials, from static to dynamically sourced supply chains, goods, processes.
Fascinating. That piece, by the way, of enterprises having a similar set of tasks, it's something we talk about and we see at Joyous a lot, which is this idea that Joyous is used a lot for, I guess, operational improvement or operational excellence. And you would think that all of the challenges that you have within your enterprise are, I'll use the term relatively unique. I know that's not a correct term, but yeah, you'd have the sense that, these are specific to us. But what we've found in doing, millions of conversations now on topics related to operations, is that actually there's a pretty finite set of things which organizations are just trying to improve even. So let alone things they're working on, the things which they're trying to improve. And so I'll give you an example. One of the common things is reducing repeat activity. And that might be, in an industry as different as a hospital system versus a telco, that's still something they're trying to do. And you go, okay, well, that's okay, that's kind of global. But you'd be surprised once you break it down into smaller components of what sort of repeat activity or what's generating that repeat activity and so on, you find they're often quite similar. And it's interesting for us because obviously we build AI models to try and understand this stuff. And one of the things that AI models love is some level of consistency and repeatability, right? And it's been a fascinating exercise for us, which I guess actually segues me into the next question. So you're talking about low latency and 5G connectivity, and I guess that we were sold this idea that AI would be driving trucks before we knew it, and it doesn't seem that AI is replacing truck drivers right at the moment, but it is being used to fill out forms and do kind of office work.
Yes. So here's my thesis, and I think Rodney Brooks and others have spoken about this. And in fact, there's a thing called Moravec's paradox that says it very well, which is humans are good at things that machines intrinsically are not, and vice versa. That's a version of it. But it's not coincidence. We invent machines that do things that we can't. And those types of things are things that are computational or repeatable or mathematical or logical. Those are things that machines can be coded to do. What machines are really crappy at, but we are really good at, because we've got a couple of million years of evolution, is we're good at physical world things. We understand the physical world without having to compute it, because we've got a brain that essentially has been optimized for physical world analysis. So after a bit of stumbling around as a 2-year-old, you pretty much figure out the physics of the physical world pretty quickly, and the same with every other aspect. So we intuit physical world things, and the machines will struggle there. But we are very poor at scale math, scale computing, scale logic, right? Because our intuition, unfortunately, forces us to make leaps that are not really quantifiably defensible. So we're very good at qualitative and physical world understanding. We're very bad at quantitative and scale. So the paradox isn't really a paradox. It's we invent machines that are symbiotic with us. And that's how AI is going to evolve. Generative AI we can get onto a bit, because of course it starts impinging, I would say, impinging but not infringing on some of the physical world things we do. But even then, it's only just creating possibilities that we will have to parse for physical reality. So I think this idea that AI is going to drive autonomous vehicles, it's wrong. It's just fundamentally wrong. And Rodney Brooks has this website called Not in My Lifetime. And I agree with him. Not in my lifetime, because AI will not understand the physical world. And driving a car is a physical world task. There are exceptions. If I could have a convoy of trucks in a dedicated lane, I can parameterize the problem well enough that that's probably okay. It's essentially a train, right? And self-driving trains have been around for a while. And there are other things, like on campuses, if I have a defined AI lane of vehicles on a limited scenario where pedestrians can't intersect, there aren't potholes in the middle of the road, it doesn't rain, there aren't trees with leaves and things that obscure points of view. So I think the idea of an autonomous thing controlled by AI that's moving around the physical world isn't going to happen, except in constrained environments. In the real world, the big wide area world, it's going to be humans closely supervising machines, as we always have done. And that's how I see the world unfolding. But you're right, repetitive tasks, form filling, designing things where I just need optionality, writing contracts. I saw DNA or protein folding, right? There's another one where AI has come in and said, look, it's actually just too complicated to compute, but I can generate patterns based on patterns I've seen. So I consider that a design task. AI is going to be good at those things because intrinsically it's beyond the scale of what humans are good at.
It's interesting, isn't it? I think that there's, I'm not really sure what the psychology of this is, but I think that people sitting in offices writing code were feeling pretty, or not just writing code, anyone working in office was feeling pretty comfortable that their jobs weren't going to be taken by AI anytime soon. And they were talking up what would happen in those labor markets, which include people like truck drivers. And before you knew it, we use Copilot at Joyous. It writes code that is certainly helpful to a junior developer. It's not quite replacing one, but it's certainly kind of helpful. I think there's often this thing too, you talk about the physical world. The other thing too is that it's almost the physical human world that the machine sometimes doesn't understand. So I'll give you my anecdotal example, which was I was driving around in San Francisco and there was a autonomous vehicle, test vehicle on the roads, right? They kind of come out in the evenings often, and you can tell them because they're covered in cameras and things. And interesting, your own psychology is immediately to treat them as a second-class citizen. You don't treat them like another driver in a car. I mean, you really don't. You just start to go, oh, it's one of those damn autonomous vehicles. But I went into a one-way street, and one of those narrow streets in San Francisco, and there was an articulated truck turning a corner into a driveway, and it had just got itself stuck. And so the driver had got out, and he knew that he was in trouble, but now there's all this traffic backing up. And so he did what a responsible truck driver did, which is he started directing traffic to basically U-turn out of this little piece of the one-way road and drive away. You should have seen this autonomous vehicle try and deal with that situation.
Because the guy's waving at it, right? Trying to get it to move in according to his instruction.
Yeah. So look.
But I like your point, Mike. There's another McKinsey report from the Global Institute, which does good work, that says exactly what you said, which is blue collar is less under threat than upper level white collar, as it used to be called, because a lot of the tasks that used to be done, generative tasks that seemed intellectual, but in fact were repetitive, and perhaps humans were limited in their ability to really do them creatively. They were just repeating a learned behavior. More under threat from generative AI are those roles. And I like the justice of that there's a rebalancing of perhaps employment value away from high-ranking executives and more towards physical world interacting individuals that will sort of renormalize perhaps the economics of that, which in the US in particular are way out of whack. And I like the fact that these things renormalize, and AI seems actually, generative AI, to possibly be a catalyst for going back to perhaps a more balanced recognition of value.
It's really, really interesting, isn't it? So just broadly then, generative AI, what are the opportunities it actually does create for the enterprise?
Yeah, I think it's those tasks that not physical world tasks. So let's put the ones where you're interacting deeply with the physical world, all those to one side. But where you're creating digitally things that, whether it's written or image or video or code or folded proteins or playing game, I think generative AI will expand our creative possibility massively. And then our role is to edit and select from those materials that are generated, much as people did think of interior design. Your interior designer, not that I've ever used one, but I've seen the shows on TV, shows you options and say, look, these three things, you could have it this way, or this way, and you pick one, right? And I think that's my model for generative AI is it will produce options that have quite sophisticated descriptors associated them now with the prompt engineering and problem formulation, and maybe even based on private data sets, which then are used as that text gets embedded, and that embedding into a vector gets used by a large language model or a visual format foundation model that generates stuff of some value, and the value will be decided by the human. But to me, that's an incredibly valuable task. I've got a creative resource for every digital task I might want to perform. I've got a perfect personal assistant that will even learn my behaviors if I want it to. So I see that as where generative AI takes us. And that's a good place if people are willing to leverage it and not be afraid of it and repel it, because then, of course, you can be run over by that. But if you can use those skill sets, it's no different than using a computer. When I started my PhD, people still typed their thesis on an IBM typewriter, right? And then there was all the Tipex you used to white out and replace and repair. And word processing was meant to put admins out of work, or because everyone could do their own typing, and it didn't. It just meant that people could do some of it first, and then have someone copy, edit it, or so on. So I think that's it. It's going to be an assistant to humans. It's going to augment humans is the term I like to use, not replace humans, but it will replace some of the jobs they do. And so they'll have to find ways to fill that time with other value add contributions. I think that's what's going to have to happen.
Yeah, I talked to a pretty senior VC the other day, and he was lamenting almost this, well, not lamenting, it's probably the wrong word, but he was concerned about the future of venture from the perspective that they put money into early stage companies. And the reason that venture really exists is because in tech companies, there's quite a hill to overcome to get going. There's a lot of technology to build before you get revenue coming in and so on. And his, I'll say concern in inverted commas, was that hey, actually you're reducing the size of that hill right? Because with generative AI, you actually need less engineers to get going on something. So if you're a solid founder who can write some code, maybe you can just do a lot of it by yourself because you've got so much more ability to do it. Now that's talking exactly to your point, which is that, hey, you're actually just making humans more productive effectively. But it was fascinating to hear it from his angle, which is like, oh, one of the big impacts I see is that this actually removes part of the need for early stage venture.
For larger amounts of capital, which is why the US has done so well, of course, in VC world, is because they can throw an awful lot of money at something compared to, say, European VCs. So the larger the amounts, the better the US does because it's more hyperbolic or better capitalized. Yeah, it's interesting. I like that one, but I would extend it to that's companies in general. Companies now might be able to do with 10 people what they used to do with 100 or 1,000. And so small companies can have a parent scale, a virtual scale, if you want, that well exceeds their size. And I think that's fantastic for innovation, right? Because if the new innovation paradigm is 10 people rather than 1,000 people and a very sophisticated set of tools they can access to generate new product designs, new capabilities, new code bases, test ideas early, write test scripts for the code they've written. Wow, you're going to get a lot of creativity unleashed with less capital invested. So great. I think to me, that's a portent of not doom. It's a portent of equality and equanimity that perhaps the world has been waiting for.
Really, really interesting, isn't it? I mean, I just at a very sort of human level, one of the things that we've noticed at the moment is that the speed of change has been rapid. No one expected that large language models would jump on the back of computing power and a few algorithmic changes in the sort of latter part of 2017, 2018 to suddenly in 2023 just be outperforming almost every other model that had come before. And the interesting thing is if you're an org like Joyous, where your data science team is less than 10 people, you look at the stuff and go like, oh, hang on, we can utilize that. Whereas if you're a larger org and you've got 100 people in data science or 1,000 people, there's a whole lot more of this inertia that goes, oh no, the models we built here are better models or whatever. And so they actually haven't tended to jump on the like the large language models or as quickly as the smaller companies have, which is similar to your point really. But it does lead me into an interesting thing which you touched on, is this idea of being afraid of the technology. And I definitely see that a lot. I in fact, the way I classify it as in the enterprise, you've got some enterprises that seem to be quite scared of using the LLMs, whereas they should probably be more scared of not using them, if you know what I mean.
I do. I've seen a lot of good quotes around that. Is your job won't be replaced by generative AI unless you don't use generative AI, right? Because you will be left out in the cold of the new version of your job. And so that you should jump on that. And although it is a bit of a bandwagon, it's clearly a bandwagon going somewhere. I think we've got past the point where it's uncertain that it's going somewhere productive. It is going somewhere productive. How exactly and how far, we don't know. But jump on the bandwagon and leverage it, because your job will get better. You'll get more valuable. If you don't, you'll be left behind. And that's probably the biggest jeopardy, is fear and ignorance will keep you outside the future potential. And that you should avoid. So embrace, take it as far as you can, and be rational, right? Don't be irrationally panicked that your job is going away anytime soon. As I say, human augmentation is how the world works. Machines assist and augment humans. This is just another one of those. It just feels a little bit more threatening because it sounds like a human. It sounds like it has insight because it talks in natural language. It generates images that seem compelling to us and that represent our world. But it doesn't know, right? It's completely, I call it sort of a digital minor bird. You remember those minor birds that used to have in pet shops that just repeated whatever they heard? It's sort of like that. It's able to generate more than it's just heard, but to some extent it's just a mimic. And a mimic based on a huge data set, and you shouldn't ever be threatened by a mimic.
One of the great examples to me is when you get ChatGPT to do maths. Right? And because we have a construct for doing maths that we were taught at school, and so we kind of understand how you multiply numbers together and how that works and so on. But it does an approximation of maths by looking at maths that other people has done without any understanding of how it works. So the example you can give,
and it does it quite well until it doesn't.
Yeah. So if you ask it, 256 times 12, it will know that when two numbers multiplied together and the last two digits are 2 and 6, then the last digit of the new number will be 2, because it's just seen that in all of the knowledge that it's seen. It's seen that happen a lot. And it'll be able to do the same thing for the first digits of the numbers too, by the way. So it'll get that right, but the bits in the middle, it will just have to approximate. And I think that's a good example, though, of, one of the challenges is that your generative AI is imperfect. The direction of travel is definitely such that that it gets better and better. So we often think this. We often go, okay, well, this particular model we've built in our data science team is outperforming, say, GPT-5. But we also know that if we go another year of working on it, precision of GPT-5 will probably pass us. So is it worth putting another $1 million into developing our model, or is it better just to kind of wait for one of the large language models? And I think that's one of the things which people are struggling with a little bit at the moment is, I asked it to write an 8-line poem about Marcus Weldon. It wrote a 5-line poem. It's like this sort of approximation of what you want.
It's approximated, and maybe justifiably, I wasn't worth the 8 lines. So I'm not sure they got that wrong correctly. But I think, so what's interesting to me recently, so I'm working with a bunch of companies on AI strategies. I have a bit of a background in AI. I should point out what my computer science undergraduate degree did quite a bit on neural networks, when neural networks were one of the previous peaks before the AI winter. And then there was an AI summer a few years ago to do with convolutional neural networks and image recognition. And then another, what looked like a fall at least, or an autumn. And now we're, of course, in another blooming spring/summer. So in one of those previous eras, I worked on AI. So one of the things that's really interesting is happening now is these prompt constructors or problem formulators that know which foundational model to use. So you can ask, or you frame it that says, if it's so think of them as a parser of the query. And if the query involves math, it calls a math engine and doesn't even bother going to the large language model for math because it knows it's crap. But when it's making sense of that number and putting it in a linguistic context, call the large language model with the numerical value that you got from a math model. And if it's more complicated math, you might use Wolfram's AI model, right? And obviously for images, you use a visual foundation model. But this utilities like LangChain now allowed you to write very sophisticated constructed problems and call and link to the right tools for that part of the problem. So when you're asking it a multiplication thing, like multiply these two numbers, use the result to do something else and predict something, that multiplication step, you say, use this foundation model. And then when that answer comes back, send that into maybe an LLM to explain in words the utility of that, or the magnitude of that answer, or the height of that thing, right? Because maybe it's the height of a building and you want to compare it to other buildings and whatever. So you want someone to do some sort of language around that. But I think these constructs are incredibly clever, that you can chain together different foundation models that do the things that they do well. And this is where the protein folding one comes in. That's just another foundation model.
Interesting, isn't it? I think what we've discovered quite quickly is that at the moment, you're kind of mixing models a lot, right? And we're often surprised, in fact, by what the large language models are actually good at, right? So I'll give you the example of clustering. It's clustering, this idea where I've got a bunch of different short pieces of text and I'm trying to understand which ones have consistent themes. So clump them into clusters. And GPT is not really great at clustering. It's not terrible at it. Clustering is such a long, extensive field of study that you can probably construct yourself a better clustering mechanism. When it comes to something like naming those clusters, obviously an LLM is going to do a great job of naming those clusters. It's going to outperform almost anything. But one of the things which people don't realize that LLMs can often be quite good at is actually error detection within those clusters. So while it can't necessarily do the cluster well, if you then say, okay, well, these 1,000 phrases have been clustered together, find ones which don't match. It does a very good job of those sort of things. And so I'm just using this as an example because what we're finding is this whole world of experimentation at the moment, right? Where you can actually go out there and say, okay, we've got a lot of different models. We've got some super powerful models that are high precision in some things and low precision in others. And we kind of have to work that out. But I do concern myself a little bit with this, we're computer scientists. That's what the folk at Joyous fundamentally are, software engineers, data scientists, etc. And so we can get this. But I think that there is this other thing which I'm slightly afraid of. It's very, very hard to tell with large language models what is accurate, precise information, and what is the kind of those numbers in the middle of the multiplication result that have just been fudged to complete the sentence.
And I think the answer has to be use private data sets more and more for the initial query So that limits the parameter space to valid, and that wouldn't necessarily use LLMs at all. It might use some other embedding technique and another foundational model to get to text that you then submit as tokens into your LLM, and an LLM just describes the answer but doesn't actually generate the origin of the answer. It generates the language that describes the answer, but the origin of the answer came from somewhere else that actually had validity. So I think that's why I'm seeing the world is there's this phase of pre-processing that generates the valid construct. Throw that pre-processed thing into an LLM that then generates very powerful text and the ability to interact with that answer, but it doesn't actually do the original thinking, right, or the original computation. And then I'm more certain that validity went into the model with all the erroneous cases not there because they were removed by an intelligent model, and the LLM just talks.
So in the end, this is a finger in the air question, but do the large enterprises basically end up with their own LLMs built on their own internal knowledge? Is that what happens?
No, I think they end up with they've pre-processed and built vector databases of all their own data using a bunch of tools that are also provided by OpenAI and others. So they do a lot of their pre-processing of their data to do the text embedding. That then allows them to construct queries that pre-process the query, and then the output of that goes to the LLM, which is a public domain LLM, I think, that just talks based on words that it's been supplied as tokens, but it doesn't actually know what it's saying, and it's not trained on those tokens. It's just, because in the end, even the intelligent models have to talk human language, right? So the tokens that come out of those models are consumable by an LLM in a way that makes sense. You and I use the same words to talk about computer science or chemistry or biology as an LLM would, but we've used our background to create a limit or a common understanding of what we're talking about that removed some of the just arbitrary strangeness we could have used with the same words because we had an education that says these are how the words go together. So I think if you do that pre-processing to create the embedding that gives you the valid way of talking about things, let's put it that way, and then the LLM talks about those things, I think that works. And I think then public domain LLMs are there and you use them to generate language, but you have private domain pre-processed data sets that are not available to others that enterprises own. Does that make sense?
It makes perfect sense to me. I'm kind of wondering about the people who are making decisions in the enterprise, whether they're just because of the rate of change, how quickly this stuff actually gets absorbed, and whether we don't see a kind of knee-jerk negative reaction rather than a piece of embracing, as you put it, a huge fillip to human productivity.
I think the clever enterprises, and I'm working with a few, already see that this is the way the world is going to be, and are reassured that that partition I've just described between pre-processing based on their private data sets and then using an open source or public LLM to generate compelling language around that. That division is comforting, right? Because it says if you want a walled garden of stuff that they can control and then throw it over to the LLM to talk about that in a meaningful way, that reassures. So once you understand that, you can say, oh, I'm going all in on this thing because I don't lose control. I, in fact, might even improve my control because I can pre-process all that data that I just had sitting in databases. I don't know what to do with it, but I can use all these new tools to parse that and create vector representations of it, whether it's a video or databases full of numbers or text. If I pre-process all of that, finally it's available, but no human could have read it. And now I've got this thing that can, to some extent, read it and tell me about it. And that's the LLM. So I think the smart ones realize this could be the magic pill, the silver bullet that has meant that the big data era that frightened everyone because no one knew what to do with all that data and nothing really helped, becomes optimized knowledge, the optimized knowledge era rather than the big data era. And I think that should be compelling to most enterprises.
Yeah, I mean, look, if you think about it in the terms of, enterprises are incented to outperform. That's the basis of the enterprise, certainly of the great multi-generational enterprises particularly. And I think it is one of those things where this is an opportunity to outperform, isn't it? At some stage it becomes base state, but like right now, it's like a lumpy environment where you can outperform because of it.
You can outperform, and you've got an infinite set of resources that cost a relatively small amount compared to the equivalent number of people that probably you couldn't access. AI was becoming unaffordable because it was $500K in the US per AI engineer. Suddenly I don't need all those AI engineers myself. I need to train my staff to be able to write prompts and intelligently parse in pseudocode form my data sets and then submit to an external resource. I think it's an era of great boom. Instead of doom, I would say it's a boom in enterprise productivity that is upon us. By the way, I haven't said this, but I think tools like Joyous can become incredibly important because you need to reassure, you need people a way of giving feedback as they're all moving into this new realm, right? And feel like there's a dialogue either with the expert or their manager, or they get a way of being handheld through this process and educated through this process and giving feedback through this process, because it is a human transformation process. So I think there will be a set of tools like Joyous needed to actually help people make this transition.
It's a fascinating thing, isn't it? Thanks for saying that, because we've really started to realize that the strength in Joyous is this combination between human conversations, right? Like I suggest something that I think will make my job better, particularly if I'm someone on the front line doing work in the real world and I get responded to by a human. And that's a conversation. And that's that little piece of conversation is where we actually learn, right? So someone says, hey, I don't know, what are the challenges when you install fiber boxes in the home? And someone comes back and goes, I often have the wrong screws. And then a human goes, oh, that's interesting. Tell me more about that. And it's, oh, I have wood screws, but we need drywall screws or something like this. And it's the conversation that actually, firstly, makes it real for the humans involved. But it's also the data set, Marcus. Like, it's the actual human conversations that create the data set. And then we couple that with AI. So it's this human conversations coupled with AI is the bit which we see as it's that interface between the AI and the humans. Now, I'm talking in quite vague terms here, but we see that's a whole kind of category of intellectual and software development over the next little while is that nexus.
I agree, and I think you can even imagine adding to Joyous and tools like Joyous the capability to generate text that explains something. One of the problems I find is people don't want to take the time necessary to generate an explanation, right? And it does take a while, right? To if you wanted to explain a whole proposition or a way to do something. But if you can live generate that and just tweak it a little bit, say, oh yeah, I can explain this, and you say, yeah, that's roughly right. And a chat GPT based again on perhaps some private data sets could have learned how to describe something in a way that was helpful to someone. And as we all describe according to our own way of understanding, but if there could be another way of having it explained and say, try thinking about it this way, I think it's something very reassuring that the person said, yeah, maybe my explanation isn't right. Try this way, which is very hard for a person to do because they think about it one way. But if there could be, again, back to the idea of generating other explanations or ways of explaining something, that's hugely helpful, I think, to someone.
Isn't it? There's a deep irony in this that you talked about $500,000 data scientists. Isn't it interesting that almost the first jobs that go are the data scientists?
It is funny. They set themselves up very well in the US in particular. And now where they go is, of course, in generating the LLMs and parameter doing even larger LLM generation. But to some extent, that's a bit of a cranking of a handle, right? There are, of course, great innovations in how to reduce the rank of those LLMs and all that. But now they go a bit behind the wall again and not in the front line. I think that's probably right, because in the front line, they were getting a little bit too much credit. But earning that much money for the task they were performing was perhaps overblown. And now what matters is people who can physically understand the physical world and people who can communicate effectively. And I think it's rather nice.
So in summary, for the worker, for the working person, what's the impact over the next 20 years of this kind of wave of AI?
I think if I start with what's the ideal thing a human needs, we would all want an optimized personal assistant that knew us and could answer any question we have within the context of how we understand things, which we all understand differently because we make our own mental models. We were taught in different ways. We read different books. And that's what generative AI in principle can become, is an advisor. And with all advisors, you have to error check, but an advisor that provides contextually relevant, mostly correct information with the need to check on any subject of relevance to us so we can make better decisions at all points in time. And I think it benefits the least educated in the end, possibly more than the most educated, because there are more questions they might have about topics that they need explanation than perhaps the highly educated. So I think there's a rebalancing it provides. Now, of course, the downside or the possibly negative outcome is if people become suspicious of this, it's probably the inverse in that the less educated become more suspicious than the perhaps more educated. But if that doesn't happen, or if that can be navigated successfully, I do think this is a great way that educational leveling happens, or information and knowledge leveling might be the way to put it, happens, and we end up with more harmonious societies with better equality, not exact equality, but better equality, and more efficiently undertake tasks. That's the potential. Whether we get there or not is, of course, depends on so many variables. But I think that's very exciting, and no one should be afraid of that as the potential outcome. You can be fearful of the path or negative versions of that scenario, but the positive version of it is very exciting for all levels of humanity and education and socioeconomic background.
Marcus, what a hugely optimistic way to finish this. I think the idea that it leads to a more equitable world is you've got to set your eyes on the goal to get there, right? And I think that should be something that we all strive to, from government policymakers through to the enterprise, individual managers, right down to the individual. Is that that is the opportunity that is in front of us. So let's hope we take it. Thank you so much for your time today. It's been absolutely awesome chatting with you, Marcus.
Well, thanks, Mike. Great conversation. Enjoyed it very much, and hopefully of value to beyond the two of us.
Well, it's certainly of value to me, if that's enough.
It's enough for me for today. Thanks, Mike.
Thanks, Marcus.
This has been the Joyous Podcast, brought to you by Joyous, human conversations and AI analytics in one. Find out more at joyoushq.com. If you liked this show, make sure to give us a rating on Apple Podcasts or wherever you get your podcasts. And be sure to join us for our upcoming podcast with Amy Edmondson, who coined the term psychological safety. This episode of the Joyous Podcast was hosted by Mike Carden and produced by Kai Crow, Karen Rayner, and Brandon Berman. Thanks for joining us. And remember, everyone deserves to be joyous.